Hi there. Before we get back to the wheel, I want to show you a step of equations that they did not put on the wheel. So I want to take you step by step through these so it will be the easiest process possible. And so therefore I want to look at this type of equation before we go back to the wheel. But we will go back to the wheel very soon. So at the end of after two-step equations where we worked those, I'm just drawing a line and continuing. You can start a brand new page if you want to. But we're looking in this video at separated variables. Okay? And that sounds scary, but I promise it will be okay. If you're following me to this point, this is just the next little baby step in the process. So let me give you an example of one of these problems. Let's do 6x subtract 10 plus 3x equals 35. So we're going to draw our power t, and we're going to say, okay, this side is clearly constant and the other side has the letters on it, and you probably already see the difference in this equation. We actually have a 6x and a 3x. So we have variables in two terms. Now, fortunately, we have the same variable. We don't have 6x and 3y. If we did, that would be a completely different situation. But since both of the variables are x's, we need to start there, and all we have to do is combine them. So 6x plus 3x gives me 9x. And then I'll copy the 10 and the 35. And then we're back to this type of equation that we had up there. We know how to solve that. We just have to combine that 6x plus the 3x to get the 9x. So then I'm going to move the 10 and copy 9x and 45. And then I'm going to divide away the coefficient, the 9. And that gives me 45 divided by 9 is 5. This is already standardized for me. I just need to put the equal sign in there. So x equals 5. So this is a baby step toward more difficult equations. Okay, number 2. We have x minus 20 plus 2x equals 35. And let's go ahead and put a 1 in front of the x. It needs a coefficient. So draw the power t and label the variable side. And 35 is by itself over there. That's clearly the constant side. And then we need to combine variables. This is called combining like terms. We have the 1x plus the 2x. And let me write that for you. This thing that we're doing, if you go to college, your algebra teacher is going to call that combine like terms. And they're like terms because they both have an x. So 1x plus 2x is 3x. And we'll minus 20 and bring down the 35. And then we're ready to solve now that we have combined our like terms. So I'm bringing the 20 over to the constants team. And I'm copying the 3x and then the 55 on this side. This is interesting. Divide by 3. I think this may have been a misprint. I copied these off the internet. I don't think they meant for us to get a decimal, but that's okay. So 3 into 55. 55 divided by 3 is going to be 18.333 repeating 3's out there. And that's okay. Those are numbers. There's nothing to worry about. I'm going to put it as a fraction though. I know that those 3's that repeat are equal to a third. So stop the repeating by making a fraction, or you can put 18.33 with the line over it. Either way would be fine. So sometimes you get fractions in your answers, and that's nothing to panic about. It just happens that way in real life. Okay, number 3, I clearly need a clean sheet of paper, so let me find one of those, if I can find one of those, and we will do some more of these problems. Let me just bring in 3 sheets of paper while I'm doing this, and I won't have to stop and do it again. Okay, so problem number 3. I have 2x minus 16 plus 2x equals 28. So draw your power T to organize, and your variables are on the left. Let's bring it to one variable because we need to get it down to one variable, and then constant on the right. So let's combine like terms. We have 2x plus 2x. That's a total of 4x. Copy the 16 and the 28. So add 16 to both sides and cancel. And then on this side, you should get a 44. Then let's divide away that coefficient. Cancel, copy, and standardize. Okay, problem number 4. If I can fit it in here. Remember, I told you these are going to get to be very long problems, and we're getting there. I'm having to squeeze in my numbers right here. So I have 3x minus 12 plus 9x equals 72. Draw your power T and label. This will be the variable side, and this will be the constant side when I'm done. Then combine like terms. So we have 3x's plus 9x's to get 12x's. Then subtract 12, and 72 gets copied. Then move the 12 to the constant side, and you're left with 12x equaling 84, and 12 gets divided, that coefficient. Cancel, and that is not 4, I'm sorry. 84 divided by 12 is 7. I'm just making up stuff, and that's not good when you're trying to learn how to do these, especially if you want to get the right answer. All right, number 5. We have 9x minus 10 plus x equals 30. And here is the variable side. Here is the constant side. And we need to combine our like terms. Now with that 1, I'm going to go ahead and put a ghost 1 in there, just so we can see the coefficient. 9 plus 1, that gives me a total of 10 x's. And I copy everything else. Then add your 10 to get it on the constants team. And 10x is 40. Divide away the coefficient. So x is worth 4 in this problem. That is your standardized solution. X equals 4. Number 6. I have 3x minus 20 plus 2x equals 15. So let's draw the power t. Variables are on this side. Constants are on this side. And I need to combine like terms. 3x plus 2x is 5x. Subtract 20 is 15. Then I will add 20 to both sides so that I can cancel it here. Copy, copy. And then I will divide 5 from both sides, and I'm left with x is 7, already in standard form. Okay, number 7. I have 5x minus 52 plus 6x equals 25. Power t. Variable side, constant side. Combine like terms to get 11x minus 52 and then a 25 on that side. Then I'll add 52, cancel, copy, and then I'll divide my coefficient 11 from both sides. X is 7. We're getting a lot of 7s in this exercise. Okay, number 8. $35 equals 6x minus 25 plus 6x. Power t. This time the variables are on the right, and that's okay. That's going to happen sometimes. Combine like terms. So I get 12x, subtract 25, and then on this side I just copy my 35. I need to move the 25. So I'm left with 12x's and a 60 on the other side. Divide both sides by the 12, and I get 5 and x. Standardize it to say x is 5. And that was number 8. Number 9. 12 equals 2x minus 8 plus 3x. Constant on the left, variable on the right. Combine like terms. So we get 5x minus 8 and a 12 on the other side. Add 8 to both sides. Cancel. Copy. And then divide by the coefficient 5. Copy again. And then I need to standardize this one. X equals 4. And finally, number 10. I have x plus x minus 100 equals 12. Power t, variable on the right, the left, constant on the right. Combine like terms. X plus x, put your ones in there if you need them. 1 plus 1 is 2x, minus 100 is 12. And this time the x's were side by side. It doesn't matter. The process doesn't change. So we're going to add 100 to both sides. Cancel. Copy. Divide by the coefficient 2. Cancel. Copy. 112 divided by 2 is 56. And this one's already standardized, so I don't have to rewrite it. I just need to put the equal sign back in there. Okay. So hopefully those were not too horrible. Those are practice with separated variables. Now I'll go back to the wheel and show you the last 2 examples on the wheel, and then we'll do some more problems. We've got one more set to do, and you'll be done with algebra equations. So I will see you in the next video, and we will be back on the wheel.